Grounding refers to connecting electrical circuits to the earth, while bonding connects conductive objects together for safety. Metallic conduit does not automatically ground the circuit within. Conduit must be properly bonded to serve as an effective grounding conductor. Water pipes may not provide a reliable grounding path due to corrosion on non-metallic sections. By understanding the proper installation and maintenance of grounding and bonding systems, one reduces the risk of electrical shocks, fires, and damage to equipment. Adhering to industry standards and codes ensures that electrical systems meet safety requirements and avoid potential fines. Properly grounded and bonded systems minimize electrical noise and interference, resulting in more reliable and efficient operation. It's crucial to continuously expand your knowledge by firstly, attending industry workshops and training programs, secondly, reading technical books and articles, thirdly, participating in online forums and discussions, and fourthly, seeking guidance from experienced electricians or professionals. By staying informed and questioning established practices, one can continue to refine your understanding of grounding and bonding systems and ensure the safety and integrity of electrical installations. Electrical grounding and bonding are vital for safety and proper functioning of electrical systems. Grounding provides a path for fault current to return to the source, tripping a circuit breaker or fuse and preventing electrical shock hazards. Bonding ensures that all metallic parts of an electrical system are at the same electrical potential, reducing the risk of shock. The National Electrical Code, or NEC, provides comprehensive guidelines for grounding and bonding. It is important to understand and follow these guidelines to ensure safe and compliant electrical installations. A grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metal underground water pipes. The grounding electrode system must be properly connected to the equipment grounding conductor system. The equipment grounding conductor system provides a path for fault current to return to the source from non-current carrying metallic parts of electrical equipment. Bonding jumpers are used to connect metallic parts of an electrical system together, such as metal conduits, metal enclosures, and metal equipment frames. Bonding jumpers must be sized according to the NEC. Ground fault circuit interrupters, or GFCIs, are required in many locations to protect against electrical shock hazards. GFCIs detect ground faults and quickly interrupt the circuit, preventing a dangerous shock. Surge protective devices, or SPDs, protect electrical equipment from voltage surges caused by lightning or other events. SPD should be installed at the service entrance and at sensitive electronic equipment. Proper grounding and bonding can also improve the performance of electrical equipment. Ground loops can cause noise and interference in electronic equipment. Proper grounding and bonding can minimize ground loops and improve signal quality. Static electricity can also damage electronic equipment. Proper grounding and bonding can dissipate static electricity and prevent damage. Understanding the difference between grounding and bonding is essential. Grounding connects electrical systems to the earth, providing a path for fault current. Bonding connects metallic parts of an electrical system together, ensuring that they are at the same electrical potential. The size of grounding and bonding conductors is critical for safety. The NEC specifies the minimum size of grounding and bonding conductors based on the size of the overcurrent protection device. Using undersized grounding and bonding conductors can create a safety hazard. The materials used for grounding and bonding conductors are also important. Copper is the most common material used for grounding and bonding conductors. Aluminum can also be used, but it must be properly sized and installed. Corrosion can damage grounding and bonding conductors, reducing their effectiveness. Grounding and bonding conductors should be protected from corrosion. Regular inspection and testing of grounding and bonding systems is important to ensure their continued effectiveness. Ground resistance testing can be used to verify the effectiveness of the grounding electrode system. Continuity testing can be used to verify the integrity of bonding connections. Proper documentation of grounding and bonding systems is essential for maintenance and troubleshooting. The documentation should include the location of grounding electrodes, the size and type of grounding and bonding conductors, and the results of grounding and bonding tests. Improper grounding and bonding can have serious consequences, including electrical shock, fire, and equipment damage. It is important to follow the NEC guidelines and best practices for grounding and bonding. If you are not familiar with grounding and bonding, consult with a qualified electrician. Grounding and bonding are not the same thing, although the terms are often used interchangeably. Grounding refers to connecting a circuit or piece of equipment to the earth. Bonding refers to connecting two or more metallic parts together to create an electrically conductive path. The purpose of grounding is to provide a low impedance path for fault current to return to the source. This helps to trip the overcurrent protection device, such as the circuit breaker or fuse, and prevent electrical shock. The purpose of bonding is to equalize the electrical potential between metallic parts. This reduces the risk of electrical shock if a person comes into contact with two or more metallic parts that are at different potentials. Grounding electrodes are used to connect the grounding system to the earth. Common types of grounding electrodes include ground rods, ground plates, and metal water pipes. Bonding jumpers are used to connect metallic parts together. Bonding jumpers must be sized according to the NEC. The equipment grounding conductor, or EG, is used to connect the non-current carrying metallic parts of equipment to the grounding system. The EGC provides a path for fault current to return to the source. The grounded conductor, also known as the neutral conductor, is intentionally grounded at the service entrance. The grounded conductor carries current under normal conditions. Ground fault circuit interrupters, or GFCIs, are designed to protect people from electrical shock. GFCIs detect ground faults and quickly interrupt the circuit, preventing a dangerous shock. Surge protective devices, or SPDs, are designed to protect electrical equipment from voltage surges. SPD divert surge current to ground, protecting the equipment from damage. The NEC provides detailed requirements for grounding and bonding. It is important to understand and follow these requirements to ensure safe and compliant electrical installations. Grounding and bonding are essential for electrical safety. They help to protect people from electrical shock and prevent damage to electrical equipment. Learning about grounding and bonding is an ongoing process. Stay up to date on the latest codes and standards. Attend training courses and workshops. Consult with experienced electricians. The color codes for grounding and grounded conductors are important for identification. The equipment grounding conductor is typically green or green with a yellow stripe. The grounded conductor is typically white or gray. Never use the equipment grounding conductor or the grounded conductor to carry current under normal conditions. These conductors are for fault current only. Always disconnect power before working on electrical equipment. Use a voltage tester to verify that the power is off. Wear appropriate personal protective equipment, or PPE, such as safety glasses and gloves. Be aware of the potential hazards of electricity. Electricity can be dangerous if not handled properly. If you are not comfortable working with electricity, consult with a qualified electrician. Grounding and bonding are complex topics. There is a lot of misinformation out there. Be sure to get your information from reliable sources. The NEC is the primary source for grounding and bonding requirements. Mike Holt's books and training materials are also excellent resources. Online forums and discussion groups can be a good way to learn from other electricians. However, be sure to verify the information you receive from these sources. Grounding and bonding are not optional. They are required by the NEC for all electrical installations. Failure to properly ground and bond electrical systems can result in serious injury or death. The NEC is updated every 3 years. Be sure to stay up to date on the latest changes. The NEC is available for purchase from the National Fire Protection Association, or NFPA. Many states and local jurisdictions also have their own electrical codes. These codes may be more stringent than the NEC. Be sure to comply with all applicable codes. Grounding and bonding are essential for electrical safety. Take the time to learn about these important topics. Your knowledge could save a life. Grounding electrode conductors, or GECs, connect the grounding electrode to the electrical system. GEC must be sized according to the NEC. Bonding jumpers are used to connect metallic parts of electrical equipment together. Bonding jumpers must be sized according to the NEC. The main bonding jumper, or MBJ, connects the grounded conductor to the equipment grounding conductor at the service entrance. The MBJ must be sized according to the NEC. The supply-side bonding jumper, or SSBJ, is used to bond metallic parts of the supply side of the service. The SSBJ must be sized according to the NEC. The equipment grounding conductor, or EG, runs with the circuit conductors. The EGC provides a path for fault current to return to the source. The size of the EGC is determined by the size of the overcurrent protection device. The grounded conductor, also known as the neutral conductor, carries current under normal conditions. The grounded conductor is intentionally grounded at the service entrance. The ungrounded conductors, also known as the hot conductors, carry current to the load. The ungrounded conductors are not grounded. Ground fault circuit interrupters, or GFCIs, protect people from electrical shock. GFCIs detect ground faults and quickly interrupt the circuit. Arc fault circuit interrupters, or SIs, protect against fires caused by arcing faults. SIs detect arcing faults and quickly interrupt the circuit. Surge protective devices, or SPDs, protect electrical equipment from voltage surges. SPD diverts surge current to ground. Transient voltage surge suppressors, or TVSSs, are another type of surge protective device. TVSSs are typically used to protect sensitive electronic equipment. Isolation transformers are used to isolate electrical equipment from the power source. Isolation transformers can help to reduce noise and interference. Grounding and bonding are not a one-size-fits-all solution. The specific requirements for grounding and bonding will vary depending on the type of electrical system and the location. Consult with a qualified electrician to determine the appropriate grounding and bonding methods for your application. Proper grounding and bonding is essential for electrical safety. It protects people from electrical shock and prevents damage to electrical equipment. Take the time to learn about grounding and bonding. It could save your life. Regularly inspect grounding and bonding connections to ensure they are tight and free of corrosion. Use antioxidant compound or aluminum conductors to prevent corrosion. Replace any damaged or corroded grounding and bonding conductors or connectors. Test grounding systems periodically to ensure they are functioning properly. Keep accurate records of grounding and bonding system installations and tests. Follow all applicable codes and standards when installing and maintaining grounding and bonding systems. Hire a qualified electrician to perform grounding and bonding work. Educate yourself and others about the importance of grounding and bonding. Grounding and bonding are critical components of a safe electrical system. By understanding and following proper grounding and bonding practices, you can help to protect yourself, your family, and your property from electrical hazards. Remember that even seemingly minor electrical work can have serious consequences if not performed correctly. Always prioritize safety and consult with a qualified electrician when in doubt. Continuing education is crucial for staying up to date on the latest electrical codes, technologies, and best practices. Attend workshops, seminars, and online courses to expand your knowledge and skills. Share your knowledge and experiences with others in the electrical industry. Participate in online forums, attend local chapter meetings, and mentor aspiring electricians. By working together, we can promote electrical safety and ensure the integrity of electrical installations.